Everyone, and welcome back with Mrs. Struble. Today we're going to be talking about one-step inequalities. First, we're going to discuss how to solve those one-step inequalities. Then we're going to figure out how we write those one-step inequalities statements in order to help us solve real-world situations. I'm also going to throw in a little bit of review on graphing these inequalities. So before you get started with this video, make sure that you have learned how to solve equations and also even how to graph inequalities. So let's go ahead and get started. Let's talk about solving one-step inequalities. Solving one-step inequalities is very similar to solving equations in that we are still going to use those inverse operations in order to help us isolate those variables on one side or the other of that inequality statement now. However, big difference here is that you need to remember that inequalities have infinitely many solutions. There's also a little hiccup when we come to multiplying and dividing by negative values on both sides. So we'll get into that as well. Let's start by adding or subtracting. So here I have three different examples. Let's go and work them one by one. And remember, our goal here is to isolate the variable. We want the inequality on, we want the variable on one side of that inequality statement, whether it be on the left or the right. It needs to be all by itself, guys. So right here we have a minus 5 is greater than or equal to 7. In order to isolate a, get a all by itself, we must add 5 to both sides. Use that inverse operation. So we're going to add 5 to both sides of this statement. These 5s on the left-hand side, they cancel out, and we are left with a. That inequality sign just falls straight down. Just like the equal sign would, we're just going to drop that straight on down. And then 7 plus 5 gives us 12. So we have a is greater than or equal to 12. In the next example, we have negative 6 plus b is less than negative 5. Again, our goal is to isolate b. So we want b all by himself. We have to think about what must be done in order for that to happen. We have a negative 6 right here. The inverse of negative 6 is a positive 6. So instead, whoops, I did say 6, right? So instead of adding a negative 6, we're going to add a positive 6 to both sides. So adding a positive 6 to both sides, again, 6 and negative 6, they cancel out. We are left with b is less than, and then 1. Final example here, negative 23 is greater than c minus 17. Okay, again, isolating that variable, we need to add 17 to both sides. What we do to one side, that's right, we do it to the other. Okay, the 17s cancel into a 0, and c plus 0 every day, all day, no matter what c is. Again, that inequality sign, let's just drop that straight on down, and then we're left with negative 23 plus 7. Negative 23 plus 7, everyone, if I am doing my math correct today, should give you a negative 6. Now, let's review how to graph these inequality statements. Going back to the first example here, we ended up with a is greater than or equal to 12. Okay, so we need to come up with a graph that represents all possible solutions for a. That's what we do when we graph. We're representing a whole list of numbers that could be a. So, using a number line, and really our only important number here is the value that's kind of our guideline to a. It's not necessarily equal to a, but it's our guideline point. A can be equal to 12, so we're going to have that closed circle right there on 12. It can also be greater than 12. I'm looking at your number line. These are your negatives, these are your positives. So when we go greater on the number line, we are going to the right. And that's that one. Okay, this is the graph that represents A. B. To graph B, we're going to start at 1. That's our magic number. Now, B is less than 1. It is not equal to 1, so we have to put an open circle, and any numbers less than 1, they're going to be to the left-hand side on that number line. So we're just going to color in that left-hand side, and this tells the reader anything less than 1, but you cannot equal 1. I can get as close to 1 as I possibly can, but I just cannot equal it. Let's go ahead and graph C. And remember, folks, if I'm going too fast at any point in time, just make sure that you pause the video and then you can catch up with us. All right. This last example says -6 is greater than C, but we need that in terms of what C is. So sometimes the best approach here is to figure out what numbers C could equal. Could C equal -6? Is -6 greater than -6? And the answer would be no. So we know right now that it's going to be an open circle. Now the question is which direction? It is set up a little differently. Okay? If you wanted to, you could just flip the whole inequality statement. But let's think of it in this way first. Okay? What value could we put in here to make -6 greater than it? In other words, what value would be less than -6? And you might say things like -8, -7, what about -10? All of those values that you just stated are less than -6. So those are all of the values that C could be. I'm going to go ahead and show you that flipped version I was talking about. All you do is you take the left and the right and you flip-flop them. Excuse me. But you also had to take this inequality statement and flip it too. And there you go. Addition and subtraction. Moving on, let's talk about multiplication and division. I told you there was a hiccup here, but let's practice those basic ones first and see what we get. All right. 3a is less than -27. I see multiplication between 3 and a. Inverse operation says to divide by 3. What I do to one side, I do to the other. Still no difference than when you did equations. These 3's are going to cancel out. We get 1 times a, which all day, every day is a. And then -27 divided by 3. -27 divided by 3 is going to be -9. Okay? The inequality statement just falls down, and there is that one. A is less than -9. Okay. Let's take a look at the next one. -54 is greater than or equal to d divided by 9. Again, our goal to isolate that d, that divided by 9 is in the way. So the inverse operation would be to multiply both sides by 9. Those 9's end up canceling out. We're left with d on the right-hand side, and -54 times 9 is actually 486. Again, the inequality symbol drops down. Oops, and I forgot to write this in purple, didn't I? Okay. All right. So far, there has been no difference, really, other than, hey, instead of an equal sign, we're working with an inequality. So why is multiplication and division different? What happens? Here's what happens. We must flip the inequality when we're multiplying or dividing both sides by a negative value. Okay? And here's the why. Say I have a statement that says x is greater than 4. Okay? So give me a number that could be greater than 4. Well, 5 is an easy one. So 5 is greater than 4. We all agree that this statement is true, yes? Good. What if I take both sides of this inequality statement and I divide it by a negative, or I multiply it by a negative number? let's say multiply that by -2. So now I have 5 times -2. And then on this side, I have 4 times -2. Okay? According to the multiplication property of equality, this should be true still. This should still be a true statement. However, it doesn't work out that way because now we have -10 on the left and -8 on the right. -10 is not greater than -8. It's actually less than -8. Okay? What we ended up doing was making this statement an untrue statement when we multiplied it both sides by negative. One way to think of it is this way. When you multiply or divide both sides by a negative number, you're flipping your number line, which means you have to also flip that inequality. So to make this inequality true, I would have to say that -10 is less than -8. So I'd have to flip the inequality to make it once again a true statement. I did not change my value of x. I just had to flip that inequality to remain true to it. Let's do a couple examples of this. Here on the left-hand side, we have -2f is less than or equal to 10. Again, inverse operations say, well, I'm multiplying by -2, so let's divide both sides by -2. Take a look at what we just did. We divided by -2 on both sides, which means we have to flip that inequality. I would suggest flipping it right now. Oh, I wrote down -2 on both sides, or dividing by -2 on both sides, not subtracting 2, because that's not a negative, okay? That's subtracting a +2. So dividing by a negative, I flip the inequality right away. Now I can do my problem as I would normally. Okay? -2 divided by -2, and we have f is greater than or equal to -5. This is still a true statement. F remains the same value from the given statement to our new found statement. Okay? Over here, -108 is greater than -h divided by 3. Again, inverse operations. I want to get rid of that negative and I want to get rid of the 3. So I'm going to multiply by -3, both sides. Okay? I multiplied by -3. Flip that inequality right now. The 3's cancel. And the negative cancels, sorry. That also cancels out of there. We're left with h on the right-hand side all by himself, which was our goal. Then on the left-hand side, 324. Okay? So h is greater than 324 here. All right. Phew. Now, that was a lot to take in. Hopefully you paused the video, rewound it, took it at your own pace. Here's a look at some try it problems that I'd like you to pause the video, try them out on your own, and we'll talk about them here in a second. Now that you've paused the video and tried them, let's talk about them. Number 1, you should have gotten b is less than or equal to 5.5, or 5 5/10, 5 1/2, whatever it may be. And here's what the graph would look like. Closed circle going to the left. In fact, all of our graphs should be going to the left. So all of our answers ended up being less than. Here's some common mistakes that I see. You know, again, new learning, but as a reminder, when we multiply or divide both sides by negatives, the inequality must flip. So number 2, for example, you should have gotten x is less than 12, because when you multiply both sides by -3 to get 12, that inequality needs to flip in order to remain true. taking a look at number 4. Number 4 is another one that is most often missed, simply in that the m is on the right-hand side to begin with. So we have a fraction multiplied by the variable. We're going to end up dividing both sides by 6/5. So negative 12 divided by 6/5. So we're dividing by a fraction multiplied by the reciprocal, and we end up getting negative 10. So negative 10 ends up on the right-hand side. M is on this side and negative 10 is on the left side. So we have negative 10 is greater than or equal to m. In order to graph inequalities where the variable is on the right-hand side, the entire thing flips, remember. Okay? So m is now less than or equal to negative 10. Same thing with 3. When you're flipping that inequality statement, make sure you also flip the inequality sign. And there you have it. All right. That is a long description of how to solve inequalities. We also need to cover how to write inequalities. Now, hopefully you have reviewed or previewed the writing and graphing inequalities video before this one. So all that's left is to just a little bit of review and then go over what inequality keywords are. So writing one-step inequalities. First step remains the same when writing inequalities as you would write an equation. Okay? Identify the variable. What is your unknown? What are you trying to figure out? Okay? Then you're going to find those essential values. And I say essential values because oftentimes there's possibly 1 or 2 other values that really do not pertain to what we need in order to find our answer or what we're looking for. So make sure any values we utilize are essential values here. Last but not least, we're going to mark any key operation words that we see. So keywords that you find in equations also happen when we're dealing with inequalities. The only addition here is now, instead of saying just is for our equal sign, because we're dealing with an inequality statement, we have 4 different categories that could mean of words that could mean less than sign, greater than sign, less than or equal to, or greater than or equal to. So go ahead and make sure you've copied those down, and let's go ahead and do an example throwing in our inequality keywords now. Okay. So in this example, a device extracts no more than 37 liters of water per day from the air. How long does this device take to collect at least 185 liters? Now, first up, let's identify our variable here. What are we trying to know? We're trying to figure out how long, okay? That's our unknown, that's our variable. So how long is the time? You could say L, X, whatever it may be. This is our variable. Now that we've identified our unknown, let's find those essential values that we need. Well, however long it is, our goal is to get at least 185. So 185 is an essential part of this mix. 37 up here is also an essential value that we need in order to write our inequality statement. Okay. Let's identify any other operational words as well as our inequality sign. Okay. All right. Now, it says we have 37 liters of water per day, okay? Which means every day, no more than 37. So 37 is what we call our maximum every day, all right? So 37 is our daily value. How many days is it going to take to get to 185? Well, at least 185. So at least is another key word that we cannot overlook. So we got to pay attention to the no more than 37, but that we don't need that for an inequality statement. all that's telling us is that that's the maximum amount per day, okay? Per day or per X. How long? We're going to do days, okay? So we're going to say 37 per, well, 30 per means multiplication. 37 times our variable, in this case, we're going to change it to D for days, needs to be at least. Taking a look at your inequality symbols chart that I just handed you, at least is the same thing as greater than or equal to. Okay, so 37D is greater than or equal to 185. We have our inequality statement. Now solve that statement and we figure out that it's going to take us at least 5 days in order to collect 185 liters of water. Okay. So there's the solution. All right, and that is how you write one-step inequalities. Thank you for joining me today on this journey of how to solve one-step inequalities, and also a quick snippet of how you use that to help write one-step inequalities in order to model real-life situations. Thank you for joining me. This is Mrs. Struble with Struble Math.